In Cascadia, we have something called the Cascadia subduction zone.
The Cascadia subduction zone starts in Northern California, runs up along the Oregon coast and the Washington coast, and ends up around Vancouver Island.
It's the intersection of two different tectonic plates. So one of them is the North America plate, which is the actual continent that we live on, and the other one is called the Juan de Fuca plate, and it's out in the ocean. And the Juan de Fuca plate is going underneath the North America plate.
Over very long periods of time, the subduction has led to the formation of the Cascade volcanoes, the Coast Range, and the very rugged coastline. And then over shorter periods of time, the Earth gets stuck and it lets go at times.
Now, most scientists are quite certain that Cascadia does indeed produce very, very large earthquakes, perhaps even giant earthquakes, and that it has a long history of doing so.
We now know that we have three major types of earthquakes in the Cascadia region. We have deep earthquakes, such as the 6.8 magnitude Nisqually earthquake in Seattle in 2001. We have shallow earthquakes that occur along crustal faults throughout the region. And we have subduction zone earthquakes, which are large ruptures along the subduction zone between the North America and Juan de Fuca plates. And these events have happened repeatedly throughout history.
We know that based on the timing of the last earthquake, which was on January 26, 1700, that there was a very large tsunami that occurred off the coast of Western North America. That tsunami eventually reached Japan, and it was the evidence of that tsunami reaching Japan that really pointed the finger to the big earthquake occurring along the Cascadia subduction zone.
The last one was about 300 years ago in the year 1700. And there haven't been big earthquakes since then. We think perhaps that we're just getting ready for the next one. And one way to measure that is to put GPS instruments on the surface. And in a lot of western Oregon and Washington, you can actually see that relative to the rest of North America, those regions are moving eastward. It's pushing them at a rate of half an inch or so per year. So what's going to happen if the plates suddenly let go? The whole region of western Oregon and Washington, it's going to suddenly lunge westward towards the Pacific Ocean. It's going to create a large earthquake.
The ground is going to shake for 2 to 4 minutes along the I-5 corridor from north of Vancouver, BC, well into California. And we know that there are pieces of our infrastructure that will not do well with this long, sustained shaking.
And then if the seafloor is uplifted during that lunging, then it's likely to make a giant tsunami as well.
So it'd be huge. And a big piece of real estate moving that much, of course, will move the surface of the ocean. And in this particular location where we're standing right now, it'd be about 20 minutes before the first wave would arrive.
In the next big earthquake, it will be comparable to what we saw in the 2004 Sumatra earthquake.
In Cascadia, the difference is, though, that the story is going to be probably more dominated by the earthquake than the tsunami.
By having lots more geophysical instrumentation through programs such as EarthScope, we have a much clearer picture. We're zooming in on very specific parts of the Cascadia subduction zone.
One of the most exciting discoveries of the past decade is the realization that the Cascadia subduction zone slips slowly on a regular basis. It's about every 14 months under Puget Sound and Vancouver Island. Each of these episodes is equivalent to a magnitude 6 or 7 earthquake, except that the slip occurs over 2 weeks rather than in a couple of seconds. And this slip, measured by the GPS instruments, is accompanied by an increased intensity of background seismic tremor. The tremor is occurring up and down the Cascadia subduction zone.
When we started putting in continuous GPS stations, we didn't know we would find these transient events in Cascadia. Programs such as EarthScope have provided or put in place an unprecedented coverage of not only of GPS tracking stations, but also very dense seismic network coverage. And I think once we get this mass of data accumulating, we will find the next order of subtle changes. And who knows, they may be the key to a much tighter definition of when the next earthquake is likely to occur.
EarthScope is like a moonshot. It's exciting science as it's happening. And just like in the 1960s, when we could only imagine what it was like to walk on the surface of the moon. Now we can see what's happening inside of the Earth because of programs such as EarthScope.